So we have seen the blood pressure regulation, and in that the most important thing what we are going to see is the short term and the long term control of blood pressure. Okay. So in the short term control of blood pressure, the main thing what we are going to see is the neural regulation. So this neural regulation of blood pressure by the short term mechanism, it is going to be mediated mainly by the baroreceptor reflex mechanism. So as the name baroreceptor reflex mechanism, what it is going to do? Baroreceptors, they are the receptors which is going to identify the deviation in the pressure. So the pressure variation is going to be picked up by these baroreceptors, and it is going to give the signal to the higher controlling center, that is in the medulla, which is called as the vasomotor center in the medulla. From where these baroreceptors is going to get the signal? From where the pressure receptors is going to get the signal? It is from the carotid and aortic bodies. The aortic body, see the heart, and you are getting the aorta which is coming out from the left ventricle. So at the place where the aorta is coming out, at the arch of aorta, you will have the carotid artery, and then the point where you will get, you have a small dilated structure. They are called as aortic bodies. So these aortic bodies, they are the baroreceptors which is going to pick up the pressure which is coming out of the heart. The blood pressure which is coming out of the heart, that is being sensed by these baroreceptors. And these baroreceptors will give the signal to the medulla through the vagus nerve, which is the 10th cranial nerve. And these vagus nerve will go and give the signal to the vasomotor center in the medulla. Then immediately the pressure balance will be mediated. How it is going to mediate? How this pressure balance is going to be mediated is, for example, when there is in the baroreceptor mechanism, we will see a small flowchart. For example, when the blood pressure is increased, the reason may be of any reason. There are so many reasons, okay? So what immediately the baroreceptor, it will do is, it will give the signal to the vasomotor center. And the vasomotor center will be immediately inhibited, because usually these vasomotor center causes vasoconstriction. Vasoconstriction means it will increases the peripheral resistance, it increases the blood pressure. Normally this is what is happening. But in our case, there is already increase in the blood pressure. So we have to give the signal which inhibits the vasomotor center. So vasoconstriction is inhibited, and there will be decrease in the peripheral resistance, and that will cause decrease in the blood pressure. So this is how the blood pressure which was increased is brought back to the normal decreased blood pressure. Okay, so this is one of the regulatory mechanism which is mediated by the baroreceptor. And there is one more neural regulation which is called as Fmge reflex. This is the brain bridge reflex, which is specifically for the regulation of heart rate. And this was going to be mediated by the stretch receptors. So these stretch receptors will be stimulated, and it also causes the signal in the maintenance of vasomotor tone. So the blood pressure will be brought back to the normal level. So these are the two regulatory mechanisms which is happening by the short-term regulation of blood pressure, and this is by the neural reflex. And there is also a regulation by the chemical reflex, that is chemoreceptor. They are baroreceptors, and there is also chemoreceptor reflex mechanism. In detail, this chemoreceptor mechanism, as the name, it is going to sense the amount of oxygen, that is the partial pressure of oxygen which is in the arterial system. So how this is going to be regulated, we will see in the forthcoming respiratory regulation. Okay, and then next one is the long-term regulation of respiration. So whatever we have seen, the baroreceptor reflex, Bainbridge reflex, and the chemical receptors, chemoreceptor mechanism, they are all coming under the short-term regulation of blood pressure. And now dealing with the long-term regulation of blood pressure. So when there is a deviation in the blood pressure, and if it is of enormous amount for the long period of time, it has to be rectified immediately. So that is by the long-term regulation of blood pressure. So how this is going to do the function? The most important mechanism which we will always encounter is renin-angiotensin-aldosterone mechanism. That is, we will call it as RAS. Okay, so how this is going to do its function is, for example, now we will consider the blood pressure is decreased blood pressure. How the long-term regulation of blood pressure is going to rectify it. So when there is a decrease of blood pressure, the next event which is going to happen is decrease of oxygen saturation. And that is going to give you the signal as hypoxia. Yes or no? The cells which is getting the blood supply will encounter decrease of oxygen because of decrease in the blood pressure. So immediately what will happen is this blood vessel is also entering into the kidneys, the glomerular apparatus of the kidneys, the afferent arterioles which is giving blood to the kidney. So that will also sense that there is a decrease of oxygen. And what is one of the important hormone produced by the kidney to maintain the RBC? Erythropoietin. So this is giving the signal of decrease of oxygen. In one way, this will give signal to the erythropoietin to produce more and more of RBC, to transport more and more of oxygen. Because it is just sensing that there is decrease of oxygen, but it don't know the cause why there is decrease of oxygen. Whether it is due to low BP, low volume of blood, or due to RBC less, or due to oxygen deficiency in the atmosphere. It don't know what is the cause, but it just analyzed that there is decrease of oxygen at the level of the tissues. So one thing is it will give signal to the erythropoietin production. On the other hand, in the kidney, you have the juxtaglomerular apparatus of the kidney. That is the place where the afferent arteriole is meeting with the proximal convoluted tubule. You have macula densa, juxtaglomerular apparatus, mesangial cells, Lassie cells, all those things. So these cells, the juxtaglomerular apparatus in the kidney, this is going to produce a hormone called as renin. So this hypoxic signal, now it is giving the production of renin. How? The blood entering into the systemic circulation, also entering into the kidney. The kidney is encountering there is decrease of blood pressure. It is also sensing there is decrease of oxygen because low blood pressure, low amount of oxygen entering into the systemic regions. Okay, so this renin, now what it is going to do is it is going to convert angiotensinogen into angiotensin 1. And this angiotensin 1 is converted to angiotensin 2 by the enzyme angiotensin converting enzyme. Okay, so this angiotensin 2 is produced, and this is one of the potent vasoconstrictor. So as the name, potent vasoconstrictor, it is going to do the constriction of the blood vessels. Once when the blood vessel is constricted, it causes the increase in the peripheral resistance. Increase in the peripheral resistance increases the blood pressure. Also, it increases the cardiac output, and the blood pressure is restored back to the normal level. This is one of the way how the angiotensin 2 is helping in regulating the blood pressure. On the other hand, this also gives signal to the adrenal gland to release aldosterone. What is the role of aldosterone? Maintenance of sodium retention. So what is happening over here? How this aldosterone is going to take part its role in regaining the decreased blood pressure. Now we have the problem is decrease of blood pressure. Our goal is to increase the blood pressure. So one way the increased blood pressure is by the oxygen. Hypoxia is giving signal. Okay, and other way renin is giving the signal, and this renin is producing angiotensin 2, which is making its part by constricting the vessels, and it is increasing the peripheral resistance and increasing the blood pressure. And other way, this angiotensin 2 is also giving signal to the aldosterone. So what this aldosterone is going to do? How this is going to regain the blood pressure to the normal level? How it is going to increase is, if there is low blood pressure, it means low blood pressure, low blood volume. Yes or no? So decrease in the blood volume and decrease in the body fluids. Yes or no? So if you rectify the decrease of body fluids, is there a chance to rectify this decrease of blood pressure? Yes? Yes or no? So if you control, if you normalize the body fluids, it will increase the blood volume and it will automatically increases the blood pressure. So this aldosterone is going to correct this body fluid level. How? This aldosterone is going to act in the collecting tubule of the nephron in the kidney. So what this is going to do is, consider this as the collecting tubule. So this is going to activate the sodium channel, sodium water channel in the collecting tubules. So this aldosterone, it will act on the sodium water exchange channel in the collecting tubule. So what is happening here is, this aldosterone makes the water retention in the kidney. So retention of sodium. Once when the sodium is retained, if it has not been excreted in the urine, along with the sodium, because of the mechanism of sodium co-transport mechanism, the sodium will also bring water along with it. So in aldosterone, it is going to add in retention of sodium. Sodium will not always move in a single way. Either it will do the function as a co-transporter or counter-transporter. In most of the cases, majority of the cases, if sodium is moving, it will bring water along with it. Okay, that is the maximum ratio of sodium water channel. So if you retain the sodium, when it is coming. This is how the urine is formed in the collecting tubule. So if you retain the sodium not to be excreted, it will also bring water along with it. So this way it increases the body fluids. So body fluid increase automatically increases the blood pressure. So this is the reason why if a person is encountering diarrhea or any kind of dehydration, in most of the treatment, supportive treatment is given. So what is done in the supportive treatment? Supplementing electrolytes. Okay, if it is an emergency condition, during midnight, person is having severe diarrhea, vomiting, loss of body fluids, then how will you rectify? Just put a spoon of salt and sugar in a glass of water. That will give you the excess amount of sodium that will retain the water from excreting through the kidney, urine. Urine will not excrete excess amount of sodium. So the water will not be excreted. So that is one of the immediate remedy you can do in emergency condition. Later on you find the cause, do all the investigations and identify what is the cause of vomiting, diarrhea, whatever it is. So immediately, how will you control the body fluids? How will you prevent from hypotension? In case of sudden vomiting, diarrhea during midnight, even for you people, it may happen. So you will always have salt and sugar in our house, but we don't have the electrolytes. Okay, you have to wait until the morning, the shop should open, then only you will get the electrolytes. Immediately in the midnight, how will you maintain your body fluid? How will you prevent the brain from hypoxia if there is continuous vomiting, severe dehydration? If you did not control, then the low blood pressure, hypoxia, then immediately so many emergencies will happen. So this is how you have to rectify. So that is the importance of blood pressure regulation. So this is also one of the autoregulatory mechanism which is helping in maintaining the homeostasis. Okay, clear? So up to this, the maintenance of blood pressure is over.